Welcome back, students. So in today's video we'll be talking about half subtractors. So it is a combinational circuit that performs binary subtraction. So it means that once we will be having two bits, we'll be subtracting them. Now it has two inputs. So there are two input variables and it has two outputs, and those two outputs are difference and borrow. It is very similar to our decimal concept. Like suppose if we are subtracting two numbers like 82 minus 57, let us take an example. So what is the concept of subtraction? The first digit that we are watching over here is 2 and 7. So can we write 2 minus 7 as minus 5 here? The answer is no. That is not how we perform subtraction of multiple digits. Now what we do here is there is a concept of borrow. This is what we have been taught in our primary classes. Now this borrow is 1 and it becomes now 12. So 12 minus 7 is going to be 5. So we will write here 5. Now let us extract the concepts from here only. This 5 that we have written here, this is what we called as difference. And because 2 minus 7 was not possible and we required borrow in that case, so this is my borrow. So these two are the outputs. So once we are doing subtraction, if we need borrow, then this borrow will be 1, and if we do not need borrow, then this borrow in that case will be 0. And difference is a number that we are writing once the subtraction is done. And one more thing we have to also correlate here is that once we will perform the subtraction of other two digits. Now since this 8 has given 1 as a borrow, so we are reducing it to 7 only. So 7 minus 5 is 2. So the same concept we will also apply in the binary also. So just to summarize, what we said right now is we are having two inputs which can be of any number of bits, but right now we talk about only a single bit. And then a second thing is there will be difference as well as the borrow. Like in the adders we had sum and the carry also. Now the first thing is the design procedure. Again we are stressing on those 4 steps, where the first step was we will identify the inputs and outputs and we will assign some names to them. So that step we have already done. We have identified that half subtractor requires 2 inputs and 2 outputs, and we have named them like AB, difference and borrow. Now second step is our truth table. And in truth table, what are we supposed to do? We will finish this table as per the relationship that exists between the input and the output. So we can see here for 2 inputs we have 4 cases, and we have to write down the values of difference and borrow. So you will take it like this. Actually what we are doing here is A minus B, and we will write all these cases here, just that it will be easy for you to understand. So third case is 1 minus 0 and the last case is 1 minus 1. Let us solve some easy cases first of all. Everybody knows what is 0 minus 0. So it is all zeros. So 0 minus 0 is there will be no difference and there is no need of borrow also in this case. Let us talk about the third one first. What is 1 minus 0? 1 minus 0 is 1 and there is no need of borrow here also. So 1 minus 0 is 1 and there is no need of borrow, so we write 0. Now we talk about the last case, 1 minus 1. So 1 minus 1 is 0. Without any borrow this operation has been done. So difference is 0 and the borrow is also 0. So if we note down case number 1, 3 and 4, they were very simple and you can correlate it with the normal subtraction that we know. Now the last case is 0 minus 1. Let us talk about 0 minus 1. So we know that 0 minus 1 is not possible, like I told you in the earlier case in the decimal, because the number here is greater than the upper one. So in this case we will require a borrow. So that means this borrow value has to be 1 over here. Now once we will take a borrow here from the other digit, so it will be 1 0. Now the thing is, what is 1 0? 1 0, and we are talking about the binary, so 1 0 is 2. We have said this already in our previous classes that 1 0 is 2, 1 1 is 3, right? 0 1 is 1. So 1 0 is 2. Now what is 2 minus 1? 2 minus 1 is 1. So we will say that difference is 1 and the borrow is also 1, because this is the only case where borrow was required. So in this case the truth table regarding the half subtractor is completed. Now we come to our third step, that is getting the equations, simplified equations. And I have told you already in our previous videos also that there are two ways to get the equation. One is the Boolean algebra, and we will prefer Boolean algebra if we are having only two inputs. The alternate method is you can use a K-map also. So I will first of all show you how to get equations with the Boolean algebra today. So let us talk about the difference. What is the equation here? We will identify ones and we will identify the values of a and b. So this is a bar b and this is a b bar. So the difference equation is a XOR b. And please note down, the equation that we are getting right now is exactly same that we got for the sum of half adder. So it is exactly same equation because the truth table is exactly same. So if truth table is exactly same, so obviously the equation you will get is also same. Now let us talk about the borrow. What is the equation of borrow? So in borrow you can see we are having only single entry as 1. So corresponding to that, this is the value which is nothing but a bar b. So borrow equation is a bar b. Again, if you will compare this with your half adder, their equation was a dot b and now it is a bar b. So you can see the equation is different. Now in this slide you can see the table is already completed. So if you want to get equations from K-map, so this is what K-map should look like for two input. There are only 4 cells possible, and you can see I have told you you should check row and column in order to know what is available here. This is a bar b bar, so this is a bar b, this is a b bar, and this is a b. So this position is 0, this is 1, this is 2, and this is 3. Now what is our aim? Our aim is to identify where are the inputs, where are the outputs as 1. So if we talk about the difference, we are ones having at what locations? At location 1 and 2. If we talk about the borrow, we are having it only in one position, and that is 1. So if we say this is this K-map is for difference and this K-map is for the borrow, so where do we need to fill ones? It is position 1 and 2. So this is position 1 and this is position 2. And similarly in borrow at position number 1, so that is here. Now see students, the grouping is not possible in this case because the ones are placed at corners. So there is no possibility of any group. So the rule is you have to write every single one that you have written here as it is. As it is means just check its row and column, and that already we have done. You can see this term was a bar b, this was a b bar. So difference is a bar b plus a b bar. And borrow also the same case, we are having only a single one, so we will check its row and column. So you can see this is a bar and b. So these are the equations exactly what we got in our previous slide. That difference was a bar b plus a b bar, which is nothing but a XOR b, and borrow is a bar b, and you can match it with our previous slide also, right? Same things we have got. So both methods are applicable. Now once third step is also done, now the fourth step is that we need to have a logic diagram. So before we draw logic diagrams, let us note down the equations again. That difference was a XOR b, which can be also written as a bar b plus a b bar, and then the borrow was a bar b. So one method of having a diagram would be very simple, that we will use XOR gate, and this XOR gate will give two inputs which are a and b. So this will be my difference, that is equal to a XOR b, and the same inputs with a is borrow, so we need to have NOT gate right now, a bar, and then b will come from here. So these two inputs will be given to an AND gate. So this will be my borrow, which will be a bar b. So this is one method, and this is the efficient method of drawing a half subtractor, sorry. The alternate method is by using simple things like a bar b. We will first of all draw a bar b. So this is my a bar, and then we will have b. So this will be my a and b. So this is a bar b we are getting here, and the next term is a b bar. So we can take a from here, we can take b bar from here with a NOT gate obviously. So this will be my a b bar, and now there's a plus sign means OR gate, so we can use OR gate also like this. So this will give you the difference, right? And the borrow is already a bar b, so a bar b is already available here, so we can take this line again, so we can say this line is also giving us the borrow. But this method we don't use normally because this will take more amount of gates, so that is not good for us. So obviously we will prefer this method where directly XOR gate is used along with the AND gate. So that completes the details regarding the half subtractor. I will see you in the next video. So till then, God bless you all and have a nice day.